So let's talk a little bit about doing testing. And if you're not doing end-to-end testing that fully covers what you need to be comfortable with the recommendation, then that testing is just a sales tactic. Is that correct?
I don't know.
I would say not 100%, but yes, it would be.
It would depend on the situation, really.
Of course.
Because, like, if they don't want to pay for the additional diagnosis and you're giving your best recommendation with the information that you have, then if you're wrong, then I mean, shit happens. Like,
and Jason, you're making sure that the customer is taking the responsibility for that decision instead of saying, tell me what I should do, and then I'm blaming it all on you.
100%. Like, I give them the information that I know up front. They live in the house. I don't live in the house. Mm-hmm. I've been here for 45 minutes, and this is what I see. This is what I could do to make it better, hopefully. Yeah. But
here's
at
a
the
list
end of the day,
what do you think it is?
Exactly.
So here's the question, I guess. What actionable information can you get from a truflow grid alone that allows you to make
measured
aware
you're actually measuring the flow of air through the air handler.
It'll tell you how much airflow the current equipment is delivering.
That's pretty
in its
much
current state.
Yes.
Well, Jim disagrees with that, but
it should tell me plus or minus within 3%. What Measure Quick would have told me anyways.
Right.
So can you tell the homeowner that they need bigger ductwork with no other information about the house, the load of the house, other than
I believe that is a huge knowledge gap in the industry, but no.
You could make modifications like Ben said earlier. He added a big air drop, dropped it, blah blah blah, and he dropped the size, I think.
Right, but he didn't use Measure Quick to do that work. He didn't use a truflow grid to do that.
No, he used his experience and expertise and going through the problems and static pressure. I mean, and like nobody.
He also didn't take any ownership of that decision,
right?
Because the person opted out of the comfort consult.
Yep.
So it was up to the homeowner. They knew that they're taking the sizing risk because they opted out of the comfort consult.
Mm-hmm.
So there was no
coercion. Or
would there have been any benefit to doing a truflow in that condition, Ben?
I wouldn't think so. Even given the information of the likely load range, seeing that most likely they could have benefited from smaller equipment, making the ductwork bigger probably wouldn't have done much in the grand scheme of things, especially with a modulating furnace where now it's operating,
within
20% of its capacity, 30%. Right.
Well within manufacturer specifications.
Yeah. With the exception of trying to keep the duct pressure low, but we handled that with near furnace modifications.
Right, and if you told that homeowner that they needed $10,000 or $12,000 worth of replacement ductwork in addition to this new equipment,
you wouldn't have got the job.
No, and they probably would have been pretty sad about that finished ceiling they had down there.
Yep.
What if you do $10,000 to $12,000 worth of ductwork and it still doesn't take care of their problems and do the right equipment? What do you do then? Then you have a big mess.
Yep.
Company a bunch of times. where they've gone out and increased the size of the ductwork to match the equipment.
We used to do that. That used to be a thing our company did. So we used to do duct evaluations that we no longer do. We stopped doing them because of because of warranty work, and we had to own a bunch of stuff. Had to give free equipment away, all kinds of crazy stuff. So
would you say that approach was unethical?
It was super unethical. It was a ploy for a certain department to make money.
So does that sound very similar to using a truflow grid under these circumstances?
We were using truflow grids under those circumstances for that. That's exactly what we were using. We would sell them a piece of equipment, they'd have high duct pressure, or we didn't sell them a piece of equipment, they'd have high duct pressure. We'd go in, oh, well, this equipment needs this ductwork. Here it is on duct calculator. You got this 80,000 BTU furnace, and you need this many CFM of air. Make that furnace work right. They're like, oh, how much? That's going to be $15,000. Okay, go ahead and do it. All right, we did it. Well, our house still ain't comfortable. What's going on now? Oh, well, apparently, this furnace is too big for your house. Sorry. We want to
would the right furnace have fit the old ductwork?
In some cases, yes. In some cases, no. There's always those. There's
anomalies.
Always some houses out there that need ductwork. That's just the way it
right.
is.
Yeah, yes, of course.
And usually it's return ductwork. Usually they're under returned. And in most cases, I can downsize equipment and do a bad drop and make it good enough. In some cases, I can do a bad drop with the right equipment and it's fabulous.
Right.
In some cases, I got to replace a duct system.
Yep.
Very few cases, though. And if the house is comfortable everywhere, you probably don't need to replace the ductwork. You probably need the right equipment in the house.
Yep. So the problem is at the kitchen table. The equipment that gets sold is not the right equipment, and you can't blame. It's so backwards the way that the truflow is even a thing. Like, it's just backwards thinking.
There's a place for
that's
truflow, but
that is gonna fix the problem, and it's not. It's like the Department of Energy wanting you to put a programmable thermostat up that's set for 82 cooling and 62 heat. Like, you might as well just take it off the wall and put it in the junk drawer, and you'll save 100% of your heating and cooling costs.
The truflow is a good diagnostic tool for like warranty work where you have like a new piece of equipment not performing properly. That's the place for that truflow grid.
I agree. 100%. Like, it's a great tool that can be used well in it for what it does to measure flow through the systems. But as a sales tool or to send somebody out that doesn't have any experience in the industry to stick this thing in there, how accurate do you think the results will be of like sending
the 3 other sales guys you work with, Ronnie? Can you imagine them?
Or not even that.
They got to do truflow.
Not even
Austin's the only salesperson at this company that can use a truflow grid properly.
Well, it's not even that. They're wanting to take somebody and give them 3 hours of training from another industry and send them out with this thing and stick it in the unit somehow. Like, they're going to know how to take the screws out and then get some accurate measurement where they're going to sell.
And it only takes 10 minutes, right? But it only takes 10 minutes.
Yeah. Most of our sales guys are technicians, or were technicians, not all of them.
Right.
Or they were HVAC people. Not all of them, again. But I wouldn't trust most of them, even that were technicians with that tool.
I don't trust
that other company in Indiana that you guys compete with. Most of their guys worked at CarMax 3 weeks ago.
Mm-hmm.
Jeff was there all summer, and I'd talk to him every day, and he would tell me stories about the crazy stuff that they would do. And then Jason Cecil's got this friend in Colorado, and every house gets a 100,000 BTU 5-ton.
Then he ought to just guess and give everybody a 8310. He'd probably be closer.
Yeah, right.
I mean, really. Be
Well,
closer
So-
with the
guesses.
truflow, we
Go ahead.
proved with Ken's situation where he had a dirty blower,
Dusty blower.
dusty
Dusty
blower.
blower.
And you look at the CFM that it was being delivered, and as soon as you clean the blower and look
Nearly
at
a
static
40%.
pressure,
Yeah, nearly a 40% increase in airflow and nearly doubled static pressure.
right? So the
Sounds like you caused a problem.
fan curve,
It's a good service diagnostic tool. And hopefully the system still dehumidifies as well as it used to.
well, the fan curve didn't accurately predict what the static pressure was going to be because it was something different. If you go
Well,
by
it's
the
probably-
fan curve, it should have been 0.7, and your Ken's was 0.8.
So, like, as far as the fan laws go, that is something you can use to. It's basically like an assumption of what this will do at these given conditions. So,
Really? Really?
Uh-oh.
He ran out of
Keeping
his.
us guessing.
you there?
Yeah, you dropped
Right.
out. You
Oh,
must have pushed a button or something. Say it again.
So the fan laws, like, there's fan laws that this is what's going to happen at a certain set of conditions, and you can extrapolate based on what something's doing now and what it's going to do with a different fan. And that's how all commercial, any commercial design, build, or spec stuff, that's how they come up with their duct size and everything. So in residential, there is some really badly designed piping systems, ductwork. So I don't believe that the fan laws, I mean, they apply for sure. Like CFM 1 is going to equal CFM 2, but there's so much turbulence and pressure that you can't measure with static pressure.
Right. So if you increase the flow a little bit, that turbulence could throw all of your measurements.
Well, I mean,
off some.
yeah, unless you're taking 16 different static pressure readings on the plenum on some of these things. I mean, most of y'all know that see these units. I mean, sometimes you'll have 15 pieces of 6-inch flex coming out of a plenum that's 2 feet long. Like, there's no way to measure accurately only just the static pressure on that. And then anything to do with the blower itself is the source of pressure. So if the blower is dirty or dusty, then everything's going to be thrown off. So that's something that, like, a Walmart greeter is not going to be able to assess that situation. So it's kind of a moot point to me to argue that, yes, the science is science and engineering is engineering, and we have all this, but the stuff that we see in the field is outside of design parameters so often that a lot of the engineering is, I mean, you can't just, and I don't know, I'm sure that the TrueFlow grid and all the other things that they manufacturers and everything put out to us to utilize to get systems working correctly is based in science, and it's sound science. But at the end of the day, we're working on some systems that are not, I don't think that these systems have been ever tested in any way to come to any kind of conclusion that, okay, this is going to do this. It's just
Well,
not the
they've been
reality.
thrown together, not following standards and practice.
No, I mean, it's just really bad. Like a lot of the systems I see, I don't know. I'm sure Jason Cecil sees similar because he's in a similar region as me. But I mean, I'm talking about like, it's so bad that it's hard to measure anything accurately. So garbage in to any calculation is going to be garbage out. So maybe measuring flow with a truflow grid would be helpful. I don't have one, so I don't know. But I just don't think that it's going to be as helpful as some people think it is, when at the end of the day, I mean, you're trying to get in, get out, get the people a price, or get the system fixed, whatever the case may be.
We can liken it to a blower door. It's a
Yeah.
great tool to have when the situation calls for it. It's the same thing with a combustion analyzer. So
Yeah, using it as a fear tactic to get somebody.
Yeah,
Yeah.
that's what rubs
Sale.
me the wrong way. Is like, you're going to send somebody out that has no idea what they're looking at with this tool, and then give them some report that says that
You need new
it's
ductwork.
that it's outside of these things, and we're going to have to do this to fix it. Like, that is just not going to work. I don't
That's a
care
good way to
who.
sell lots of new duct systems on oversized equipment.
Yeah, and then you're going to end up with the same problem that
That's what Ronnie was saying. Is that's what they discovered, and so you got the wrong ductwork and the wrong equipment, and you still got equipment that's short cycling because it satisfies the thermostat so fast, and those far rooms never get comfortable, and all of the things that the homeowner wanted weren't addressed. They don't care that the equipment's going to last longer. It's the wrong equipment.
I was always taught coming up in the trade that was the solution. More ductwork. It's got to be bigger.
Well,
The equipment might have to be bigger.
so more ductwork. I'm not sure that there's. I mean, you'd have to really go to town to have too much ductwork, probably.
Yeah.
So I'm not sure that that's necessarily wrong.
in my opinion, any 5-ton equipment doesn't have big enough ductwork to begin with.
No.
That's
That's usually the way that it plays out.
That's the biggest thing, is the 2.5 ton system don't have enough ductwork. The problem is at the kitchen table, and people that are selling the equipment that we have to install is not sized properly. And it even happens in commercial a lot, which you're not so concerned with velocity and noise and that kind of thing, but you're still trying to get the air where it needs to go. And even stamp engineered drawings, I'm like, dude, are you serious right now? Like, where did you steal these prints from? Because this is not going to work. It'll work for what, 5 years, 10 years, and then you're going to have major problems with the system that need repair, and it's because you printed these drawings that are not. It's just not going to work, and not to mention that it ain't going to fit in the space that you told me it would fit in. So the issue is always going to be at the kitchen table, and trying to get homeowners to in the residential sector to understand that the house is a system. You got to have the right ductwork. You need the correct size equipment, and just because it goes to 70, you got it set at 72, and it goes to 75 when it's 117 degrees outside. It's not the end of the world. The sky's not falling.
Well, that's the shift that we're going for, is trying to make what we know it to be a complicated system understandable for the homeowner, so that they can make a rational decision in their own best interest.
And that's why I think HVAC 2.0 does a great job doing
Because
that.
that is the
End
target.
goal. Yep.
Yeah, that's the end goal.
What you got, Ted?
That's, I think, about it. Shall we go to the after party?
Yeah,
Thank you,
Sure.
guys. And
seems like a wrap.
okay.